All right, we're going to talk today about more numeration systems, and specifically we're going to talk about positional number systems, Hindu-Arabic, Babylonian, Mayan, and Greek number systems. So a positional number system is one where the position of the number in the number makes a difference. So a good example is the number 24, 24, and 42. So both of them have the same face values. They have a 2 and a 4, but because of the position of the numbers, the values have different values. You have 2 in the tens place, so it's 20, whereas on the second number you have 4 in the tens place, so that's 40. So that's what we mean by a positional number system. The Hindu-Arabic system that we currently use is a positional number system. So again, we're talking about the face values of the digit and the place values of the digit. The face value, again, is just on its own, how much is it worth. The place value is when you put it into the position of the number, what is it now worth. So we always have place values, and in our system we use the decimal point and 0, and in other systems there are different bases, but that's what we're going to use. So here we have the number 45,414, and there are three fours in the number. But because of the position of the three fours, they have different values. So the first four is in the ones place, the next four is in the hundreds place, and the last four is in the 10,000s place. So they have different values. They have different place values. So to calculate these place values, what you're doing is most of you are familiar with the idea that we have the ones place, the tens place, the hundreds place, the thousands place. But when you think about why is it that, since we're in a base 10 number system, this is the 10 to the 0 place, which is 1. Anything to the 0 power is 1. The tens place is 10 to the first place, which is 10. The hundreds place is 10 to the second place, which is 100. And it keeps going, 10 to the third place, 10 to the fourth place, all the way up. So the Babylonians used a base 60, and a lot of times there was something historical about why they used the particular base they did. A lot of people feel like we use the base 10 number system because you have 10 fingers or 10 toes, and so people typically would count on their fingers or toes, and that's why we had a base 10 system. Different reasons come about. So the Babylonians, it had something to do with the calendar as to why they used the base 60. But in their case, again, since it's a base 60, there's 60 to the 0 power, which is the ones place, 60 to the first power, which is the 60s place, and 60 to the second power, which is a 3600s place. And of course, it could keep going up higher. So they had two symbols, the triangle and the arrow, and those symbols could be used to represent all the numbers from 1 to 59. So let's look at this example and we'll go through it. So if you look at the first one, think in terms of the symbols mark the different units. So all of this is in the ones place. There are 3 tens, which is 30, and there are 4 ones, which is 4. So we have 34 things in the ones place, which is 34. On this other example that I have here, what you have to do is realize that, again, once I switch back to my other symbol, I have my tens symbols, my ones symbols. So all of this is in the ones place, and all of this is in the 60s place. So when we switch, and I didn't even put 0 power there, when we switch from one place value to another, we will switch back to our original symbols. If a place value in the Babylonian system is skipped, we have to leave a blank. That's the only way we can represent it. So I have 2 numbers in the 60s place, and I have 35 numbers in the ones place. So then I would do the calculations, and I have a total value of 155 for this number. So here's what we want to do here. Sorry, on the next problem. We want to convert the number 43,233 to the Babylonian number system. Now you'll notice that there's a space here. So everything that you see here is in the ones place, and everything that you see here is in the 3600 space. There is nothing in the 60s space. Did that zero again? There is nothing in the 60s space. There's only things in the one space and the 3600 space. So we're going to take the number 43,233 and we're going to divide it by 3600, which comes out on your calculator to like 12.009 something, which means you have 12 with the remainder of 33. So I have 33 things in the ones place and 12 things in the 3600. So if we think about it, the Hindu-Arabic system, if we do 3600 times 12, we will end up with in our math here, we will end up with 43,200 plus the 33 that was left over as our remainder gives you the 43,233. Oops. Gives you the 43,233. So that's what we've done here. This part of the number represents 33. There are no 60s, and there are 12 3600s. So this is our Babylonian number, and you have to remember to leave the space between the 12 portion and the 33 portion. So the ancient Mayans used a base 20 number system. So again, you would have 20 to the 0 power, 20 to the first power, 20 to the second power, 20 to the third power. But instead, the Mayans used 360 as their third place value. So, you know, a little bit of a twist on it. So the symbol for the 0 is given to you here. The symbol for the 1 is a dot, and the symbol for a 5 is a line. So let's look at this. We want to convert this number into the Hindu-Arabic system. So the ones we already said were 5s. So we have 2 5s there, which is 10. And the 10s are in the third position that we have there. So we have 10 in the 3600 positions. We have, in this case, 0 in the 20s position. And we have 19 in the ones position. So we have 10 things in the 3600 position, nothing in the 20 position, and 19 things in the 1 position. So our number is 3,619. Let's look at another one. Here we have 8 things in the 3600 position, nothing in the 20s position, and 15 things in the 1 position. So our number is 2,895. All right, and our last one that we're going to look at is the Greek number system. The Greek number system has quite a few numerals, and oops, I think I skipped a screen. Nope, I didn't. And the Greek number system is what we call a ciphered counting number system, and they had 27 different symbols, and it was based on the Greek alphabet plus 3 extra symbols. Okay, so let's look at how this works. So if we have the Greek numbers that we have here, we know that the first number here represents the number 40. And the second number represents the number 1, so this number would be the number 41. The first symbol that we have here represents 600. If we look at our chart, the symbol for pi, very famous symbol, in this case though represents 80, and delta represents 9. So we have the number 689. Okay. I hope this is interesting. I hope you're enjoying it. Be sure to read over the section because there's so much more information that they mention in here. I'm just sort of scraping by on the surface with it for you. There's a lot of information, and we might end up having a lab coming up in the next couple weeks that involves some of this information. So I hope you have a great week, and keep in touch with me.